Okay, so welcome to your video streaming from Miss Neal's house. This is Flood Week, and I've not planned to do this, but I think it'll be helpful. So I'm going to go through these questions, and I'll talk about different strategies you can use and talk about how to solve the problems and kind of what I would think about while I was solving the problems. And we're just going to see how this goes. So you can use these as you are trying to work on these, or so you can check your answers, or whatever you need to do. So we're going to start with question 4. The teacher will determine the total number of books to order for class using the function b of n equals 4n, where n represents the number of students in the class. What is the independent quantity in the situation? So in order to solve this, you need to know that independent is the x. And so I would look back at this original equation, and if I were to rewrite it using x and y, it would look something like that. So I replaced the n with the x. So this value is the independent variable, which means the y is the dependent variable. And the n represents the number of students. So the n is the number of students, the x is the independent, replace that, so it's the number of students. The total number of books to order, that's the y, that's the dependent variable. And the number of books each student needs is the 4, which would be the slope or the rate of change. So the independent is going to be the number of students in the class. Number 9. One type of redwood tree has an average height of 65 feet when it is 20 years old. If the tree is more than 20 years old, the average height, h, can be modeled by the function, blah, 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 where a is the age of the tree in years. Which statement about this situation is true? So it's just going to be a lot of reading that you have to analyze which part is true. Letter A, every additional 1.95 feet of length over 20 feet adds 45 years to the age of this type of redwood tree. For this type of redwood tree, the average height increases by 1.95 feet per year throughout its lifetime. This one, it's not throughout its lifetime. It's only after it's more than 20 years old. So that can't be right. Each additional year of age over 20 adds 1.95 feet to the average height of the type of redwood tree. Maybe. For this type of redwood tree, the average height increases by 65 feet for every 20 years of growth. So this plus 65, that would not be 65 feet for every 20 years of growth. It's 65 feet when it's 20 years, and then each additional year is 195. So that doesn't really make sense. I skipped letter A because as I read it, I got confused and I just skipped it. So for every additional 1.95 feet of length over 20 feet adds 45 years of age. So that's just saying if it grows 1.95 feet, then it adds 45 years. That doesn't even make sense. So we're left with C. So when it's 21 years old, it'll be the original 65 plus another 1.95. So every additional year adds 1.95. Number 15. Which graph represents the inequality negative 2x plus 3y is greater than 12? Well, the first thing that I would do is because of this symbol, it cannot be this one or this one, because these symbols would have to have the line underneath it. So that's the first thing I would do. Now, in order to really understand what this is, we need to put it into slope-intercept form. So I'm going to do that down here. Negative 2x plus 3y greater than 12. So remember, I want the y by itself, so we need to add 2x to both sides. 3y is greater than 2x plus 12. I'll divide everything by 3. Y is greater than 2/3 x plus 4. I did not flip the sign because I did not divide by a negative, so my sign is this way. If you notice all these lines are drawn the same way, I just need to know which way the symbol faced. So y is greater, which means on the y-axis, I need to shade greater than it, which would be this way, so it would be A. So this symbol would have been like this. If this was right, it would have been like this, and if this one was right, it would have been like this. This is a little extra. Moving on to page 2, number 19. Which set of ordered pairs represents y as a function of x? Well, we need to know what functions are. So to determine a function, remember that means that every x value has only one y value. So in the case of ordered pairs, all my x values have to be different. Those are different. This one repeats the -1. This repeats a 3. And this repeats the 2. So letter A is the only one that has all the x values different. 28. The number of possible pairings of two objects selected from a set of x objects can be modeled by this certain formula. Which table shows this quadratic relationship? Well, because you have a calculator, which you may not right now, but in theory, you would have a calculator. Let me clear all this out. So I would just put my function into the calculator and then look at the table and find where these things start to match up. So 2 is 1, so all those are right. 3 is 3, 4 is 6, 5 is 10. Let's see, 7 is 21, not 22, so it can't be that one. Oh, you can't see that. It can't be that one. 8 is 28. 9 is 36, so it can't be that one. 10 is 45, so it can't be that one. And then 12 is 66. So this one, 12 is 66, 8, 28, 5, 10, and 2 is 1. That's what I would do. You could also plug in the numbers into here and solve to see what the y is, but that's silly. Number 35. The graph shows the cost of purchasing X small flags at a gift shop if the flags are equally priced. Equally priced, we're going to have a linear function, there'll be a straight line. Based on this information, which ordered pair represents an additional point on the graph? Well, I'm increasing by $4. So each flag is $4, but then for whatever reason, there's like a fee of 1. So this would be the equation. You could also create a table of this information. So 1 is 5, 2, 9, 3, 13, 4, 17. And then since your answer choices are 5, 6, 7, 8, you could continue that and just follow the pattern. Or use your calculator, and if you had come up with that equation, but you could do that using this is plus 4, this is plus 1, so the slope is 4 over 1, and then the y-intercept of 1, 4 times 1 is 4 plus 1, 4 times 2 is 8 plus 1, 4 times 3 is 12 plus 1. So that's how you can come up with the equation. So then you can look at the table. 5 is 21, which is not right. 6 is 25, which is not right. 7 is 29, which is right. 8 is 33, which is not right. So 729 would be the correct answer. But again, if you just wanted to create a table and follow the pattern to see when the pattern was right, you could do that. Number 44, The volume of two identical cubes is related to the edge length of the cubes. Which function represents the combined volume of the cubes? Well, you need to know about volume, that it's the length times the width times the height. So this would be x times x times x. And that would be the volume of one cube, and it says the combined, and so there's two of them. So we have 2 times x times x times x. This represents x cubed. So we have f. This would be the volume of one cube. And so times 2 would be for both cubes. The last one for this category is 54. The table shows the population P of mice in a field at the end of M months. Based on the data in the table, what will be the population of mice in the field at the end of 8 months? Well, you need to notice that these numbers are being multiplied. A common mistake would be to look at this and just multiply it times 2. That would be correct if this was linear, but it's not linear. So the best thing to do is to figure out what this pattern is, which is multiplying by 2 times 2. And so you could write an exponential equation for that. So y would equal, remember the first number is your initial value, which is 6, and then times 2 to the exponent. 6, 2, exponent x. And then when you look at your table, it's always a good idea, especially if you already have some data, when you look at the table, make sure that if you're given a table, that this at least matches. So 0 is 6, and then 12, 24, 48, 96. If this didn't match, you didn't write your equation right. So that's a good thing to keep in mind. And the question asks when it's the end of 8 months, so you would go down to 8 months, 1536. If you couldn't figure out the equation, since you're only extending it from 4 to 8 months, you could just figure out what it is for 5, 6, 7, 8, just extend your table and do the multiplication. That's also a good strategy if you can't figure out the equation, or just a way to check it if you're not sure. But that concludes Category 1 video. I'm going to do them all separately just so that you can focus on which video you need the most. And so that is it for Category 1.